Okay, so the goal of this video is going to be to set up the PR5220 for Ethernet IP and demonstrate some of the basic functions. Okay, so this is going to be very easy. We go into field bus parameters and we set up the IP address. Okay, and it's automatically set for 8-byte data transfer. That's all we have to do. Since I don't have a PLC here, I'm going to use a simulator to demonstrate the functionality. So first let's go in and set that up. Okay, so on our simulator we have to put in the same address that we put into the transmitter. Okay, and that's something that you would do on a PLC also if you had one. Alright, the next thing we're going to do is set up a class 1 connection. So first thing we have to do is set up the instance ID. It's 150 and 100. And this will be the same for any of the transmitters, controllers that we make. The data size here is going to be 8 bytes input, 8 bytes output. Okay, and we're going to select a point-to-point connection. And the rest of the parameters we can use the defaults. So there's a screen that we can monitor by looking inside the info button, and then we navigate down to hardware slots and we take a look at our Ethernet IP card. In there you can see the status says waiting for a connection. Next thing we're going to do is press connect, and now you can see that the status has changed to connected. Okay, if you look at the weight, we're not really getting the weight yet because we haven't asked for it. Before we get into a lot of reading and writing different data addresses, I just want to review the basics. Okay, so we're using this 8-byte scale interface. Okay, so that's 8 bytes input, 8 bytes output. We have MOSI, which is the master out, slave in. So that's data that's going from the master to the slave. And then we have the MISO, which is the master in, slave out. So this is what the 5220 in this case is sending back to the master, which is the PLC. When we want to request data from the transmitter, we write the address in byte 4. Okay, and then to verify that it actually got there, then we check byte 5, which is the read value selected. So that if you see the same number in the same register there, then you know that your data went through. Looking at our write window, we are going to write what we want to read in byte 4 right here. And then we're going to verify in byte 5 that it's there. And then we are going to read the data back, either going to be in 0 through 3, depending on what data we're going to read, or it's going to be in 6 and 7, so that we all the yellow areas there. That is the data that can be read. Now we're looking at the MISO. Okay, and again, the definitions here are the same, but some of the data is going to be different. If you look here at the top data, if we want to read some data from a particular place, we can have it right there, up in the first 4 bytes. And in the bottom, we can read some of the status bits, like if we're at a standstill, if we're at 0, below 0, if we have an overload, and so on and so forth. And we'll get into some examples of that later. I mentioned before that there are some function numbers that are predefined. Now these function numbers, there's some examples here on this page in the manual. Like we're going to be looking at the ones in yellow in particular. Some of the other ones maybe you might need to look at some point in the future. But for this example, we're going to be looking at those two. Alright, so I'm going to show you a little bit more detail of what that is in the next slide. For a little more detail, I'm going to look here and I'm going to see that there's 2 different types of functions. The ones on the top, the ones that have the blue heading on them, you can see that these ones here, like they have some of the same functionality as the ones below. Okay, the ones on the top, you have to turn them on and then you have to turn them off. So this way they're ready for the next command to come in. Now the ones on the bottom, the ones starting at 112, 113, those there, once you execute them, they automatically reset themselves. So there's just two different ways of programming the same function. So the gross weight is located in D8, and that is a double integer. Okay, so we go in and we go into the fourth byte, and we execute an 8, and we'll see the data change in the bottom here. Okay, so now the bottom changed to 10 and 80. So using the calculator now, we can convert from the 4424 that we see and make that into hex, and we'll see that the number is 1080, like we saw here, except that the bytes are inverted here, so we see 8010. Alright, so we're going to tear the scale now. So we go to our right window, and we're going to write directly to a bit in byte number 7. So we're going in byte number 7, bit number 1, which has a value of 2. Alright, so now we're going to execute that in here. We're going to navigate to byte 7, and we're going to write a 2 in there. And we see the scale has tared. Another thing we can check is to see if the scale is at standstill. That's bit 6 of byte 7. Now when I push on the scale, you see these little triangles there. When those are there, we know we're at a standstill, and when it's not, we know we're not stable. Okay, so now what we're going to do is we're going to check it. We're going to go to our read select value, and we're going to put a 7 in there because we want to get the value that's in byte 7. Okay, now you see here we have a 0, 2. That's because of this really bit 6 that's toggling, but due to the byte inversion, it's showing up as our first byte, which is bit 6 and 7 together. When we request the weight, we get back a double integer number, but we don't know if it's kilograms, grams, pounds. We don't know how many decimal points there are supposed to be in there, and we don't know how many, what the readability is. You know, is it 0.1, 0.2, 0.5? We can determine that by reading a function for. So scrolling down, we'll look for a function for. Okay, there it is. So now we're going to write function for and commit. Okay, if we look in the manual, we see that there are a few bytes there that are shown, 0, 1, and 2. Okay, so that would be the exponent, the unit, and the step. Now, we can look at the same things inside the transmitter. We look at the hardware, and we go down to the Ethernet IP card, and here we can see those same data bits as we see in the simulator. So I put some arrows here to show the difference between what you might find on either your PLC or your simulator as to what you see in the transmitter registers. Now, we expected to see 0, 1, and 2 as the first 3 bytes there. And that is what you see here. If you look up at the top left of your screen, we have 1, 2, 3, we have 1, and then we have 0, 1, 0, 2, and then 0, 2 again. So that is for the amount of decimal points, the units, and whether it's grams or kilograms, and the step size, whether it's going to be 0.1, 0.2, 0.5. Okay, so that's what you see up there. If you look on the simulator, you'll see there's a byte inversion, and actually those 4 bytes are inverted. Okay, so now you can see that sometimes when you try to figure this out for the first time, things don't seem to make sense, but you always have to look for a byte inversion. So you saw here that we wrote the 4, so that was for the function 4. That was up here in the read select. All right, and then we got our result here. So now we know 2 decimal points. There was a step size of 2, and the unit was grams. Actually, no, there was one digit. That was 1 decimal point, grams, and scale interval 2. So that's how you can try to interpret these readings that you get back. Next, we'll take a look at an RSLogix example. Okay, the first thing you have to do in RSLogix is you have to set up a generic Ethernet module, as you see here. Now I have 2 examples here. One of them is showing, the top one is showing DINT type double integer. So in that case, we have 2 32-bit words. In the lower section, we see we have SINT, or single integer. So here you can have 8 8-bit words. All right, so you have to set that up one of those 2 ways. The 8 by 8 is the more common. All right, so in this slide, we have 2 scales connected to this RSLogix. You see, in the lower section, we have an 8 written in the second of the 4 bytes, so that would be giving you your read gross weight. We have that in both. And then on the top, we see the data coming back in the first 4 bytes. So the first scale is reading 198, and the second scale is reading 1499. Okay, I hope you found this video useful, and I have provided my contact information just in case you have some questions. I'd be happy to answer them. Thank you.